Rangers, welcome to the 4th grade math channel of Sun Devil Learning Labs. My name is Miss Houston and I'm going to be your safari guide today as we go through our math lesson on two-digit division with remainders and decomposition. So let's go over our objectives and materials for the day. Our objective, and you guys can go ahead and say this with me, I can solve two-digit division problems that include remainders and decomposition. The only materials that you're going to need for today's lesson are paper, pencil, and an eraser. So before we begin anything else, let's practice some vocabulary. So I know throughout the week we've been talking about these words, but I want to go over them and review exactly what each one is with you guys. So first off, let's talk about the dividend. The dividend is this number 56 here. This is the number that is being divided up. So it's going to be the biggest number. So we're saying that 56 is being divided into like 7 smaller groups, for example. So this is our big number that is going to be partitioned into littler groups. Our divisor is the number 7, and that is the number that 56 is being divided by. And then the quotient is the answer. So when you divide 56 by 7, what is the answer? And that is our quotient. So these terms are important to remember. And we're going to be talking about them throughout the day too. So just wanted to give you guys a update or kind of like review lesson with them. That way we can refer back to them as we're doing our other problems today. So let's move on to our first problem then. With this one, we're going to talk about two-digit division, and we're going to use a place value mat alongside our standard algorithm. That way we can talk about the differences and the similarities between both methods. So here's our equation. We have 48 divided by 4. So what I'm going to do is in my place value mat over here, I'm going to draw a line just like this. Now in my place value mat, I only drew the ones and the tens place because we're not working in the hundreds place. We're only going to stick with the tens and the ones today. So I'm going to represent 48 in my place value mat, and I'm going to use x's. So we have 4 tens, and we have 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Now that we've represented the number 48, and I'm also going to put 48 here because this is where it belongs in our divisor equation. So we have 48 divided by 4. So the dividend goes on the inside, the divisor goes on the outside, and then the quotient belongs on top here. And the quotient's our answer, so we're going to be solving for that. Now, if we're using our place value mat, we're saying that 48, so all these shapes are being divided by 4. So what I'm going to do is I'm going to break up the bottom portion of my place value mat into 4 sections. So I'm going to draw 1, 2, 3, 4. We have 4 sections here. And then what we're going to do is we're going to take these 48 here and divide them up. So let's start in our ones place. In our ones place, we're going to just put 1x in each of my columns. Well, actually, we're going to use a check mark. That way you guys can see the differences. So we have 1, 2, 3, 4. Pretty even, right? Each box gets 1 check mark. So I'm going to, as I do this, I'm going to mark off the ones that we've already counted. So we've done 1, 2, 3, 4. Now there's 4 x's left, right? So that means that I can put these 4 into 4 columns without there being any extras or too little or too many. So we're going to put 4 more. And ta-da! All of my x's have been represented into these 4 different columns, so I can cross them out there. Now let's represent these 4 tens in the 4 different columns. So I'm going to take my check mark, and we're going to put 1 in each of these boxes because there's 4 here. 1, 2, 3, 4. So we can put each one in their own column instead. So I'm going to cross off the top here. This means that I already did all of my x's that I needed to place. So if we look at this, we already got rid of all of our tens and our ones digits, right? We already divided them into 4 different sections. So if you look at each of these boxes, each box has 1 shape in the tens column and 2 shapes in the ones column. See? 1, 2, 1, 2, and 1, 2. So this shows that each group is equivalent. So essentially, if we look at our place value mat, we are saying that 48 divided into 4 groups will give us 12 in each of our groups. So our answer is going to be 12. Now let's try this using the standard algorithm. So if we're doing 4 into 48, we know that 4 goes into 4 1 time. So I'm going to put a 1 here. 4 times 1 is 4, so we're going to put minus 4 and then do the line. 4 minus 4 is 0, and then we put the 8 afterwards, just like that. Now, how many times does 4 go into 8? 4 goes into 8 2 times. So we're going to say that 2 times 4 is 8. No, I'm sorry. 2 times 4 is 8. So we're going to put the 2 up here. And there are no other numbers to do, so we are completely done solving this. So as you can see, our quotient here is the same as our quotient here, which means that our answer to 48 divided by 4 is 12. Now, if you look at this the opposite way, we could also say that 12 multiplied by 4 equals 48, because division and multiplication are related to each other. When you do 48 divided by 4, it equals 12. 12 times 4 equals 48. 4 times 12 equals 48. 48 divided by 12 equals 4. It's just a property of division and multiplication on how they're related to each other. Let's try another example. So we're going to move on to this one. This time we're going to have a remainder. So it's important to look out for this remainder. We are doing 56 divided by 5. So we're going to write 56 is our divisor, and our dividend, and 5 is our divisor. What we want to do is we want to figure out what our quotient is. So first off, let's represent 56 in the place value mat. So we're going to grab our line tool and we're going to draw this out. We are going to represent 56 using x's. So we have 5 in the tens place, and we have 6 in our ones place. Now, we're saying that 56 is divided by 5. So I'm going to draw 5 sections under here. That way we can divide the tens and the ones into 5 different areas. So we have 4, and we need one more section. Perfect. So now that we've done this, we can divide this up perfectly. So my first step is I'm going to take my ones. We have 6 ones, right? So that means that I can put at least 5 of these ones into their own columns. So I'm going to use my check mark. I'm going to put 1, 1, 1, 1, 1. And we're going to cross out the ones that we already talked about. So we got these 3 done, and we got these 2 done. We still have this 1x left over though, okay? It's important to memorize and remember this. So we're going to come back to it. Now let's divide our tens up into 5 different sections. So I'm going to use my check mark. There are 5 tens, right? And 5 sections. So each section gets their own 10. So we're going to put 1 in each of our 5 boxes. And this is all the x's that we have in the tens place. So I'm just going to cross them all out because we have figured them all out 100%. Perfect. So are we done? Almost. As you guys remember, we have this 1x left over here. Remember, it didn't go into any of these columns. There are no numbers left. We only have a single one. We don't have any tens. We don't have any other ones. We just have 1x, like a single x left. So this 1 is our remainder because this is left over. It doesn't go into any of our boxes. It can't be equally divided out. So we're just going to say that we have an answer of 11, remainder 1. And the reason why it's 11 is because there's 1 shape in our tens column and 1 shape in our ones column. And that's the same for all these boxes here. So our answer is 11, but 11 plus that 1 extra x. So 11 remainder 1. Let's type this out where our answer box is. 11 remainder 1. Awesome job, guys. Now let's do it using the standard algorithm real quick. So we have 5 into 5. How many times does that go in? It goes in 1 time, right? So we're going to put a 1. 1 times 5 is 5. So then we got to subtract, which equals 0. And then we bring down our 6. How many times does 5 go into 6? 1 time. And then if we do minus 5, because 1 times 5 equals 1. Now there's nothing else to bring down, right? So this is our remainder because there's nothing else we can do with it. So our answer here also is 11 remainder 1. And that is our final quotient to our question. So let's move on to our next problem now. In our next problem, we are going to look at standard algorithm only. So before we were doing the place value mat on the side, and then we were corresponding it with the standard algorithm, let's try only the standard algorithm now. So we have 47 divided by 3. 47 is our dividend 3 is our divisor, and then our quotient is going to be the answer that we are looking for. So how many times does 3 go into 4? 1 time, right? So I'm going to put a 1 up here. Next, we need to do, what is 3 times 1? 3 times 1 is 3. So if you subtract 3 from the tens place here, 4 minus 3, 1. And then our next step is to bring down that 7. So we're going to bring down 7. Now, how many times does 3 go into 17? Let's try counting on our fingers. So we have 3, 6, 9, 12, 15, 18. Uh-oh, that's past 17, so we can't count that number 6, right? So we can say that 3 goes into 17 approximately 5 times. So we're going to write 5 here. What's 5 times 3? 15. So we're going to do 17 minus 15, which equals 2. Now we have nothing left to bring down, right? There's no extra number over here. So this is essentially our remainder because we have nothing that we can do with it. So our final answer is going to be 15 remainder 2. And this is going to be our quotient. And that's how we write our answer if we're using this type of notation here. But if we're using like the equation 47 divided by 3 equals, then we're going to use, and we're just going to write the answer right next to it. So I'm going to write 15 remainder 2, just like so. Awesome job, guys. Give yourselves a round of applause. Let's move on to our next question now. So we're now going to do a decomposition problem. And this decomposition problem is going to be the same thing as before, but we're going to have an extra step. So let's represent the 42 in our place value mat. So I'm going to put 4 in my tens place and 2 in my ones place. And we are dividing this into 3 separate sections. So we have 1, 2, and 3. Now, if we start in our ones place, we only have 2 ones, and we cannot divide those 2 ones into 3 sections, right? So what are we going to do? Let's look to our tens place. We have a whole bunch of numbers in our tens place, right? So what I'm going to do is I'm going to take one of these tens, and I'm going to trade it down for 10 ones. So I'm going to get my pencil tool so that way you guys can see what I'm doing. So we are taking this X, and we're going to trade it down for 10 ones. So I'm going to draw an extra 10 ones here, and we're going to cross off this X. So I'm going to add 10 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Awesome. So now that we have 12 ones here and 3 tens, right? So I'm going to write this so that way we don't have to keep counting. We have 3 tens, 12 ones. We can divide this into 4 sections. So what's 12 divided by 3? 4, right? So I'm going to put 4 X's in each of these columns down here. So we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And how many tens do I have? I have 3 tens. 3 tens can easily be divided into 3 sections, and you just put 1 X in each column. So if we look at this, looking at our tens and our ones, we have 1 shape in the tens column and 4 shapes in our ones column. So that gives us an answer of 14, right? So looking at the place value mat, 42 divided by 3 equals 14. Now let's try it with the standard algorithm. We're going to put 42 as our dividend and 3 is our divisor. Let's see, how many times does 3 go into 4? 1 time. 3 times 1 is 3. 4 minus 3 is 1, and then we got to bring down this 2. How many times does 3 go into 12? Let's see. 3, 6, 9, 12. 3 goes in 4 times. So let's put the 4 up here. And now there's no other numbers left to do, right? So we can officially say that our quotient is 14 with no remainders. So I'm going to write 14 up here also. Now let's move on to our next slide. Let's do another one. I think you guys are getting the hang of this and you're doing super great. So this one is your turn. I'd like you guys to practice using both the place value and the standard algorithm, and we're going to go over the answers once you're done. So go ahead and pause the video now. Great job, guys. Give yourselves a round of applause. You did a wonderful job doing this problem on your own. Let's go over the answer now. So our question is, what is 30 divided by 2? So first off, let's represent 30 in our place value mat. So I'm going to put 3 in my tens column. Let's get my stamp out. 1, 2, 3, and nothing in my ones column, right? Because 0 is in our ones. Now what we need to do is we need to split this up into 2 more sections and then get our other tools out. So looking at this, well, 3 tens can't be divided into 2 groups, right? That just doesn't make sense. So what if we do this? What if we change one of our 10s, we trade it down for 10 ones? So we're going to take this, just like our last one, we're going to cross it off, and we're going to put 10 ones here instead. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I think this looks a bit more manageable now, right? So what is 10 divided into 2 groups? 5, right? Because 2 times 5 is 10. So if I put 5 X's in each of these columns, I will still have the 10 ones, and it will work out perfect. Now, what if we look over in our tens place? We only have 2 shapes. That can be divided into 2 columns, right? Just 1 shape in each column. So if we look at our answer, we have 1 shape in the tens column and 5 shapes in our ones column, which means that our quotient is going to be 15. 30 divided by 2 equals 15. Now let's do the standard algorithm real quick. Our dividend is 30, and our divisor is 2. So what we're going to do is, how many times does 2 go into 3? 1 time. 2 times 1 is 2, so we're going to do 3 minus 2 equals, what's 3 minus 2? It's 1, so we're going to put a 1 down, and we are going to carry that 0 down. So now, how many times does 2 go into 10? It goes in 5 times, right? 2, 4, 6, 8, 10. 5 times. So I'm going to put a 5 up here. Now 5 times 2 is 10, so minus 10, this is a 10, not a 16, equals 0. And there is nothing left to bring down, so we're completely done. So our quotient is 15, and we have no remainders whatsoever. Awesome job, guys. Give yourselves a pat on the back. You did wonderful on this problem. Now we're going to do a word problem. And once again, this is your turn. So here is our problem. There are 51 bananas on a tree. If 5 monkeys want to share them equally, how many bananas will each monkey get? And then follow-up question, how many bananas will be left over? So this is hinting that there might be a remainder. So it's important for you guys to look out for this in case you see one. So go ahead, work on this on your own, and when you're done, come back and we'll go over the answers. So go ahead and pause the video now. Awesome job, guys. Give yourselves a pat on the back. You did a wonderful job doing this word problem on your own. Let's go over the answer now. There are 51 bananas on a tree. If 5 monkeys want to share them equally, how many bananas will each monkey get? And how many bananas will be left over? So let's do this using our standard algorithm. So I'm going to do and draw, oops, that's not super straight, hang on. So we're going to draw my little notation for division, just like that. So we are saying 51, which is our dividend, divided by 5, which is our divisor, and we are looking for our quotient. So I'm going to write this out in the other format too, so that way you guys can see. 56 divided by 5 equals 7, or 51, not 56. So what we're going to do from here is we're going to practice with our standard algorithm. So how many times does 5 go into 5? Exactly 1 time, right? So I'm going to put a 1 here, and we're going to say 5 times 1 is 5. So we're going to put minus 5 equals 0. Okay, but we can't just leave it here, right? We need to bring down this 1. Now, how many times does 5 go into 1? It can't, right? Like 5's way bigger than 1, so we can't put that in. So we're going to say that it just can't, so we're going to put a 0 here. Now what's 0 times 5? 0. So we're going to put minus 0 equals, well, it's still 1. Now there's nothing else to bring down though. So we're going to say that 1 here is our remainder. So our final answer is 10, remainder 1. Now if we think about this, what's 5 times 10? 50, right? Then 50 plus 1, which is that remainder, equals 51. So that's why it makes sense that 10, remainder 1, would be our quotient. So we're also going to write our answer over here. That way we have it in both formats. So 10 remainder 1 and 10 remainder 1. Now looking at our question, how many bananas will each monkey get? Each monkey will get 10 bananas, right? Because if there's 5 monkeys, they all get a full 10 bananas. but there's that one banana that's left over. So that's our remainder 1. So we're going to say that 1 banana is left over. Well, awesome job, guys. You did really wonderful with that. So let's move on to a discussion question. What does it mean if there's a remainder in the quotient? So what does that R mean? What does the actual remainder mean? A remainder means that it is a value that cannot be equally distributed. So for example, looking back at that banana problem, we had 51 bananas and 5 monkeys. Each monkey got exactly 10 bananas, but there was 1 banana left over. And that banana, we're not saying that we're going to split the banana into 5 portions. We're just saying, like, everyone wants their own entire banana. So there's 1 banana left over. And to make it fair, we're not going to give it to anyone, right? Because why should one monkey get 11 bananas while the others get 10? So we're saying that that 1 extra banana is the remainder because it is the leftover that doesn't really fit in anywhere. So that is what it means if there's a remainder in the quotient. Here's an overview for today. Our objective was, I can solve 2-digit division problems that include remainders and decomposition. And we did that. We talked about remainders, we talked about the vocabulary of division, and we worked on decomposition, where we took the 110 and we traded it down for 10 sets of 1s. And we were able to solve the division equations using that by trading down. Anyways, you guys all did a super great job today. I hope you enjoyed our safari adventure, and I hope that you all have a wonderful day.